Hello all. Today we are going to familiarize with some terms which are most commonly used in the discussion of organic reaction mechanisms. Without a clear understanding of such points, it will be difficult for you to understand the reaction mechanism. Okay, so the points to be discussed are substrate and reagent. What do you mean by a substrate and a reagent? Then what are the bonding notations? What is the difference between homolytic cleavage and heterolytic cleavage? And what are electrophiles and nucleophiles? So the first point to be discussed is substrate and reagent. Consider a hypothetical reaction like this. A plus B gives products. Okay. In this, A and B are the reactants, and among that, one will be the substrate and the other will be the reagent. Okay. For example, let's write CH3Cl plus OH minus will give you CH3OH plus Cl minus, right? In this reaction, the main compound which undergoes a change in the reaction is called a substrate. Okay, in that sense, this is the substrate. Methyl chloride is the substrate. Okay, the main compound which is undergoing a change in a reaction is called a substrate, and the species which brings about that change is called a reagent. Okay, here this is the species which brings about the change in that substrate. Okay, so this OH minus is the reagent here. Okay, hope the concept is clear. Next one is the bonding notations. There are four main types of bonding notations which we frequently use in depicting the organic reactions. First one is the curved arrow notation. Excuse me, curved arrow notation. Okay, this curved arrow notation is used to show the direction of electron flow in a reaction. Okay, it's used to show the direction of electron flow in a reaction, and it represents the shift of two electrons also. Okay, it represents the shift of two electrons. Here in this reaction, H2O plus HCl will give you hydronium ion and Cl minus. Okay, water plus HCl will give you hydronium ion and Cl minus. How it takes place? Let's see. Here, oxygen has, in water molecule, oxygen has two lone pairs. One lone pair is shifted to H plus, shifted to HCl. Okay, so that hydronium ion is formed, and this bond is cleaved like this, and Cl minus is the byproduct. So curved arrow notation here in this mechanism we have seen twice. Okay, in both the sections it means the shift of two electrons. Okay, so curved arrow notation depicts the shift of two electrons and it gives us the direction of electron flow. Okay, HCl എന്ത് ചെയ്യുന്നു, Cl minus ആണ്, Cl minus ആയിട്ടാണ് പോകുന്നത് എന്നുള്ളത് എങ്ങനെയാണ് ഇലക്ട്രോൺ ഫ്ലോയുടെ ഡയറക്ഷൻ വെച്ചിട്ടാണ് നമുക്ക് മനസ്സിലായത്. That can be clearly understood by this bonding curved arrow notation. And here are some examples. Okay, from carbonyl group CO, the electron shift takes place like this, and these are two more examples given. And the second one is half-headed arrow or fishhook arrow. Okay, it looks like a fish hook, therefore it's otherwise known as fishhook arrow. This is the half-headed arrow, and it represents the shift of only one electron. Okay, the fishhook arrow represents the shift of only one electron, and the product obtained and the resultant product obtained, species obtained are free radicals. Okay, so this fishhook arrow represents single electron shift. Here CH3, this is ethane in presence of sunlight. This bond is made up of two electrons, so in this one electron goes to this species and the other electron goes to this part. Therefore, we are getting two methyl free radicals. Okay, the product of the resultant species obtained by the representation fishhook arrow is the free radicals. Okay, the resulting species are called free radicals. And the third one is double-headed arrow. We are well versed with this double-headed arrow. This represents the resonance structures. Okay, these are used to represent the resonance structures. This is the double-headed arrow. And the last one is the straight arrow notation. This is the most commonly used notation to represent a reaction. Substrate and reagent gives the product. Okay, so it represents the change from reactant to product, and this is the most commonly used one. And there is one more. This straight arrow represents a reversible reaction. Okay, these are about bonding notations. And next point to be covered is homolytic cleavage and heterolytic cleavage. Okay, we can call it as homolysis and heterolysis also. Homolysis and heterolysis. Okay, so homolysis can be represented like this. A and B gives here single electron shift takes place, and we will be getting A dot plus B dot. Okay, A dot plus B dot. So this is a single electron shift. Single electron shift. Okay, in homolysis, single electron shift takes place. And the products are, as you can see, products are radicals, free radicals. Products are free radicals. And these are represented by, as we know now, these are represented by fishhook arrows. Fishhook arrows, represented by fishhook arrows. And these are initiated by either heat or light. Okay, either heat or light. And normally this homolytic cleavage takes place in the presence of a peroxide. So these are initiated by peroxide. These are initiated by peroxides. Example, let's take methyl chloride, CH3Cl, and in presence of light, homolysis takes place to give two radicals, which are methyl radical and chlorine free radical. Okay, so this is homolysis. And heterolysis just opposite of all these things. Okay, so in the case of heterolysis, it can be represented in two ways. Suppose the bond shift is like this, from A to B. Okay, A and B lekana bond shift engil, the resultant species obtained will be A plus and B minus. This A-B bond is made up of two electrons, and in this representation we can understand that two electrons are shifted to B, which means that A has lost its own electron. Okay, A and B in kudeyana AB ennulla bond undayittulladu, covalent bond undayittulladu, and by this shift endha cheyyunnathu, A yude electron kude aaru kondupoyi, B kondupoyi. Therefore A ku endana ipo ullathu, oru one electron loss aanu, adana nammal endu vechu represent cheyyunnathu, positive charge vechu represent cheyyunnathu, and B has gained another electron. Okay, B ku oru electron kude extra kittittundu, adukondu endu cheyyunu, B minus aayittu maarum. Understood? Okay, and suppose if the electron shift is like this, angane thane venamillalo, ingeneyum avalo. That depends upon the polarity of the bond. Okay, ഏതാണോ more polar ആയിട്ടുള്ളത്, more കുറച്ചും കൂടെ electronegative ആയിട്ടുള്ള atom ഏതാണോ അങ്ങോട്ടേക്കാണ് electrons normally എന്ത് ചെയ്യുക, മൂവ് ചെയ്യുക അല്ലേ. അപ്പോൾ suppose A is more electronegative than B, അപ്പോൾ എന്താണ് കിട്ടുന്നത്, ഇങ്ങനെ ആയിരിക്കില്ല. Species will be like this, A minus and B plus. Okay, so this involves two electron shift. In homolysis it was single electron shift. Shraddhikya, in homolysis it was single electron shift, and in heterolysis it is two electron shift. And the product, as you can see here, products are ions, not radicals. Products are ions. Okay, and these are represented by curved arrows. These are represented by curved arrows, and these are normally initiated by heat. Okay, light in the presence lalla, heat in the presence lana nadakka, and peroxide or any sort of any sort of initiators are not required. Okay, so ഇവിടെ peroxide ഒന്നും ആവശ്യമില്ല, initiators ഒന്നും ആവശ്യമില്ല, just heat it, you will get the resultant species. And example, let's take the same example so that it's more clear for you. CH3Cl എടുത്തു, and we are heating it. Okay, heat ചെയ്യുന്ന സമയത്ത് we know that chlorine is more electronegative than carbon, right? So normal polarity Cl delta minus CH3 delta plus. So definitely the electron shift in the direction will be towards chlorine. Okay, the direction of electron shift will be definitely towards chlorine, and therefore the resultant species obtained are CH3 plus and Cl minus. Okay, these are all about homolysis and heterolysis. Now let's see what do you mean by electrophiles and nucleophiles. Okay, so electrophiles. From that name itself we can understand. Okay, philic means towards ഇഷ്ടമുള്ളതെന്നാണ് നമ്മൾ phile എന്നുള്ള word meaning കൊണ്ട് mean ചെയ്യുന്നത്. Okay, word കൊണ്ട് mean ചെയ്യുന്നത്. So electrophile എന്ന് പറഞ്ഞാൽ എന്താണ്? They are electron loving species. Electron loving species ആണ്. They accepts an electron pair. In a reaction, an electrophile accepts an electron pair. So accepts an electron pair, and അതെങ്ങനെയാണ് കിട്ടുക? എവിടുന്നാണ് അതിന് electron pair കിട്ടുക? Electron rich centers ആണ് അതിന് എന്ത് കൊടുക്കേണ്ടത്? electron pair കൊടുക്കേണ്ടത്. So they attack electron rich centers. They attack electron rich centers, and they are themselves electron deficient. Electron കുറവുള്ളതുകൊണ്ടാണല്ലോ electron തേടി പോകുന്നത്. So electron deficient ആണ് അവര്. അതുകൊണ്ടാണ് അവരെ എന്ത് വിളിക്കുന്നത്? electrophile എന്ന് വിളിക്കുന്നത്. Electron deficient ആയതുകൊണ്ട് തന്നെ they love electrons. Okay, and these are represented by E plus, and these are either positive ions or neutral species, and all Lewis acids are electrophiles. Okay, ella Lewis acids definition thanne endana? The species which accept an electron pair എന്നാണ്. Therefore all Lewis acids are electrophiles. Example, നമുക്ക് അപ്പോൾ ഇപ്പോൾ പറഞ്ഞു പോസിറ്റീവ് ചാർജ് ഉള്ള അയോൺസ് എന്ന് പറയുമ്പോൾ തന്നെ നമ്മുടെ മനസ്സിൽ വരുന്നത് H plus ആണ് അല്ലേ? H plus. Okay, H plus. Inorganic ions നമ്മൾ പറയുകയാണെങ്കിൽ Na plus. Okay, electrophiles ആണ്. നമ്മൾ inorganic we are not discussing here. Therefore carbocations, positively charged species ആണ് carbocations. They are electrophiles. Okay, CH3 plus. And neutral species involves Lewis acids such as AlCl3, BF3, etc. Okay, AlCl3, BF3, etc. And regarding nucleophiles, നമ്മൾ നേരത്തെ പറഞ്ഞ എല്ലാ പോയിന്റ്സും എന്ത് ചെയ്യുന്നു? ഇൻവേർട്ട് ചെയ്ത് പറഞ്ഞാൽ ന്യൂക്ലിയോഫൈൽസിന്റെ ഡിസ്ക്രിപ്ഷൻ ആയി നോക്കാം. അവിടെ accepts an electron pair എന്നായിരുന്നു. ഇവിടെ എന്താണ്? nucleophiles donate an electron pair. Okay, a nucleophile donates an electron pair. They are nucleus loving species. Nucleus loving species എന്ന് പറഞ്ഞാൽ positive charge. They love positive centers. Okay, positive centers നോടാണ് അതിനെന്ത് affinity വരുന്നത്. They attack electron deficient centers. അതിനാണ് positive centers എന്ന് പറയുന്നത്. They attack electron deficient centers. They themselves are electron rich. അതുകൊണ്ടാണ് കൊടുക്കാൻ പറ്റുന്നത് അല്ലേ? They themselves are electron rich. They themselves are electron rich. These are represented by Nu minus. These are either negative ions or neutral species. Example, negative ions പറയുമ്പോൾ തന്നെ നമുക്ക് എന്താ വരാ? Negative ions Cl minus, Cn minus, OH minus, NH2 minus, etc. Okay, these are all negative ions. And neutral species, electron rich neutral species, there should be lone pairs of electrons present in it. Okay, the species such as alcohol, ROH, electron pair, 2 electron pairs are there, and ammonia, NH3, there is 1 electron pair. Okay, amines, RNH2, etc. Okay, these are all about the difference between electrophiles and nucleophiles. Okay, thanks for watching this class.